Today we're continuing with the electrophilic addition reaction, the mechanism which is one of the alkenes addition reaction. We had a couple of examples yesterday, and now we're continuing with the more examples, right? For example, if you look at this, bacho, CH3, CH double bond CH2 plus HCl. This is a propene, and we are going to react a propene in this example with HBr. First, tell me the reaction, then we'll go to the mechanism. First, if you look at the reaction, and I number these carbons, this is 1, this is 2, and this is 3. There are 3 carbons, 1, 2, and 3. So if we look at the number of carbons and react it with HBr, the double bond breaks, the hydrogen goes to the one carbon and Br adds up to the other carbon. So addition reaction undergoes. We learned it yesterday. Now, but in this case, there are 2 cases because this is an unsymmetrical alkene. What is the meaning of unsymmetrical alkene? If the alkene has this kind of structure, when both double bonds carbon have same number of hydrogen attached, so you call it symmetrical alkene. What do you call it? Symmetrical. But if it is having this kind of situation in which one carbon of the double bond having how many hydrogens? 2, and one contains 1. So this is called what? Unsymmetrical. Okay? So when you add propene, which is an unsymmetrical alkene, to HBr, now we have 2 products, 2 possible products. Because if H goes to the carbon number 1, yes, the Br is going to add up to the carbon number 2. So it will be what? CH3, CH, and then Br on this carbon, and then this becomes CH3. So this is 2-bromo. On the other hand, there is also possibility that this hydrogen could go to this carbon. What is this? Yes, it could be CH3, CH2, and CH2Br. Right? Yes. This is called what? 1, 2, 3. This is 1-bromopropane. Now, what do we expect? They should be in equal amount because the hydrogen should have equal opportunity to get attached either carbon number 1 and 2, but that's not the case. You know, the products that have been formed, the 1-bromo and 2-bromo, they are not in equal amount. Rather, 2-bromo is in a major amount. You call it a major product because in a huge amount. And what about this? This is the minor. You understand what I'm saying? That 2 of the products, one of them is in a more amount called major, and the other one is in a less amount called the minor product. So how do we decide? Thank you. How do we decide that which will be the major and which will be the minor product? At this moment, I can just hint you, I can just point out to something where you can see, but the logic comes when we have the mechanism, right? Yeah, okay, let me write the mechanism, then I'll explain. Hold it for a while. Walaikum assalam. Walaikum assalam. Khair Mubarak. Aapko bhi. Okay, let's see what is the mechanism. You know the mechanism? The mechanism is the same. When addition reaction takes place, yesterday we had been discussing, it is a 2-step mechanism known as electrophilic addition. So first, let's see the mechanism. Here it is, and it is reacting with HBr. किसी को याद है क्या होता था? This side is partial negative, this side is partial positive. पहले स्टेप में किसने ऐड होना है? H ने या Br ने? H ने. उसको ऐड होने के लिए जो इलेक्ट्रॉन पेयर है वो कहां से आए? Electrophilic addition reaction. So for first step, H को ऐड होने के लिए कौन सा इलेक्ट्रॉन पेयर यूज हो सकता है? Yes, the double bond that is formed between two carbons. This is the electron pair that is used to attach the hydrogen. Now, which hydrogen is going to get attached this? Any one, either one or two. One or two में से कोई भी इस hydrogen को इस electrophile को अपने साथ attach कर लेता है. So it becomes, let's say, two attach कर लेता है. So one attach कर लेता है, तो two पे क्या charge आ जाएगा? Positive. This is known as carbocation. Yes. But if you look at this, you have to see, as soon as you look at the carbocation, I told you previously as well, carbocations are very unstable things. So what you have to see, what type of carbocation is this? What type of carbocation is this? Is it a primary or having two alkyl groups? Two alkyl. Yes, so it's a secondary carbocation. Intermediate means that not a final product, the thing that is formed for a while, and then it's going to be turned into another product. Yes, so the carbocation, this carbocation, as you asked me, this carbocation has two alkyl groups attached, this one and this one. So when two alkyl groups attached with a carbocation, we call it secondary carbocation. We learned it in the first lesson where we defined the carbocation as C positive when it has one carbon. So it is primary. When it has two carbons attached, it is what? Secondary. Okay, when three carbon attached, it's a tertiary. But at this moment, how many carbons attached? Two. So ये कौन सा है? Secondary. और secondary carbocation में two alkyl groups, you know, have a lot of positive inductive effects, so that gives the stability to the cation. But if it goes other way around, what about this बच्चों? अगर आप कहते हैं कि नहीं, जो H है वो सेंटर वाले पे अटैच हुआ, तो फिर क्या होगा? CH2 would be positive ना, तो आप कहते हैं ये भी carbocation है. Yes, आप कहते हैं it's a primary carbocation. So there is a chance of primary and secondary, both carbocations intermediate are formed. Okay, but unfortunately we know that because of two alkyl groups attached with a secondary carbocation, that is more stable, and this is primary is, you're saying other way around, it's a less stable or kind of unstable, right? So ये एक तरह से बनता ही नहीं है. मेजर ये बना, मैं आपको नंबर से बात समझाता हूँ. इधर सुनो. Actually it's not like this, but just to explain it. How many molecules of propene? I assume 100. Please parents. And when HBr first step happens, 50 gives secondary and 50 gives primary carbocation. But primary carbocation is what? Less stable or unstable. So these one go back, turn into propene again. Only, let's say 49 go back. Only one survived. Yes. और वो 49 इधर सुनो, वो 49 फिर इधर से चले गए, इसमें जाके ऐड हो गए, क्योंकि they have to go to the other way now, ना? So how many total carbocation in this? 99. And how many total? One. So in the second step, we know, in the second step, when this PR bond breaks, ये numbers आपने नहीं लिखने, I just made numbers to make you understand. When the second step takes place, look, the Br negative comes, look at this, uses its electron pair and makes a bond with this. So that's why I'm saying कि जो पहला बनने वाला जो 2 bromo है, you know they'll be in the major amount, और इसमें शायद one odd that survived, that can turn into the product. बाकी तो survive ही नहीं किया ना उन्होंने. So it becomes CH3, CH2, CH2Br. So in numbers if I see 99 ये और 1 ये product बना, इसलिए आप उसको क्या कह रहे हैं major और इसको क्या कह रहे हैं minor. So I hope you understood my point now this more major and minor product is actually linked with what? With the stability of intermediate carbocation. Okay. So 2-bromo. So what do you write? 2-bromo. Propane is the major. Major amount product. Why? Because it's carbocation, being a secondary carbocation, having two alkyl groups attached, more positive inductive effect gives stability to the carbocation, right? So please write down it's a major, and 1-bromopropane is minor product. Reason kya hai? Look at the reason. That 2-bromopropane is formed from an intermediate secondary carbocation intermediate. So secondary carbocation. So 2-bromopropane formed from an intermediate which was secondary carbocation okay, two alkyl groups attached, two alkyl groups attached with carbocation. Give me a minute. Okay, two alkyl groups attached with carbocation. A lot of positive inductive effect. Gives stability to carbocation. As compared to primary carbocation. Okay, now I'm going to give you a question, बच्चों. आज का हमारा वही सेम है कि इलेक्ट्रोफिलिक एडिशन. सॉरी, लिख लीजिए. Yes. And this addition was given by Markovnikov's Russian scientist. So therefore you call it a Markovnikov's addition, in which one of the product is major and one of the product is minor. मैं बताने लगा हूँ. Now you see, look at this. Look at this. Have you done writing? Okay, now look at this. Once you write it, जब आप mechanism लिखते हैं, then you get it कि okay fine, ये secondary carbocation था, ये primary था, that's why secondary was more stable, इसलिए उससे बनने वाला product जो है वो major था. But without it आप यहाँ से भी check कर सकते हैं. अगर कोई आपको कहे कि नहीं, सिर्फ आप ये बता दें कि without writing mechanism कौन सा major होगा, कौन सा minor होगा, तो आपने याद ये रखना है कि जब हाइड्रोजन जो है ना एक ऐसे कार्बन पे जाएगा which is having more number of hydrogen. जैसे इसके पास कितने हैं, नंबर 1 contains how many hydrogens, और नंबर 2 1 और 2 पे जा सकता है, 3 पे तो नहीं जा सकता. 1 contains 2 hydrogen and 2 contains, so किस पे जाएगा, 1 पे जाएगा. जब हाइड्रोजन, तो मेजर प्रोडक्ट बनेगा. यानी when hydrogen goes to a carbon which is already having more number of hydrogen, अगर आपको ये मुश्किल लगता है तो एक और आसान तरीका बताता हूँ कि जब Br या Cl या OH अदर देन हाइड्रोजन जो एलिमेंट ऐड होता है, जब वो टर्मिनल कार्बन पे ऐड हो रहा होगा माइनर होगा, और जब वो इन बिटवीन द चेन ऐड होगा तो वो क्या होगा, मेजर प्रोडक्ट होगा. बट दैट्स अ काइंड ऑफ गैस एंड दिस इज कॉल्ड Marconi curves addition. You call it Marconi. ये पूछते नहीं एग्जामिनर इसका, बट जस्ट फॉर द सेक ऑफ. Yes, this is called Marconi curves addition. Okay, now I'm going to give you similar questions which you have to follow. देख लीजिए कैसे करना है. पहले दोनों प्रोडक्ट बनाने हैं. First you have to write a sign which is major, which is minor. Then you have go to the mechanism, and then first step in which you have to draw two carbocations. फिर बताना होगा इनमें से कौन अनस्टेबल है. जैसे मैंने बताया ये प्राइमरी होने की वजह से अनस्टेबल है, तो इससे बनने वाला प्रोडक्ट कम होगा. दिस इज द सेकेंडरी. मैंने इसकी रीजन दी कि दो अल्काइल ग्रुप्स हैं, इससे बनने वाला ये ज्यादा स्टेबल प्रोडक्ट है, सस्टेन करेगा और इससे आगे ज्यादा प्रोडक्ट बनेंगे. ओके, नाउ प्लीज हियर इट इज. यू हैव टू डू but1 ene reacts with steam. प्लीज बच्चों पहले रिएक्शन लिखिए फिर उसका मैकेनिज्म. तो प्लीज नो मोर. but1ene CH3CH2CH डबल बॉन्ड CH2 प्लस HOH. ये स्टीम है. You know the conditions for this reactions are very strong. कौन सी है? 350, 60 to 70 atm pressure, H3PO4 catalyst. Or issue. Okay, now first you write the product, a sign which is major, which is minor, then you write the mechanism. बस OH जब टर्मिनल पे लगेगा तो माइनर होगा, OH बीच में लगा तो मेजर होगा. क्लास थोड़ा लेट तो होते हैं क्योंकि क्लास पढ़ के फिर आना पड़ता है. स्कूल क्या 11 से दूर है. तुमने स्कूल से आना पड़ता है. बस कुछ नहीं होता. नमाज आफ्टर दिस क्लास पढ़ा करें ना, इन बिटवीन. उससे पहले निकलने से पहले जब ये क्लास खत्म होती है यहीं पे बायो वाले सर क्या कुछ नहीं होता 5 मिनट में. I'll let you go. बायो वाले सर पेज पे फिर मैं स्कूल से थोड़ा सा 1 बजे क्लास खत्म होती है सर. मैं 30 मिनट से लेते हैं सर. आज 1 बजे से लेते हैं most time for you. Did you have a timetable change? School? No, sir. I'm already जल्दी खत्म हो रहे थे. क्या टाइमिंग बेसिकली हुई है. हाँ, मैं से बोल जल्दी 42 लोग हमारी एक हो गई. You can see. That's the हाँ बैक में करते हैं. बाकी didn't lost. What are the costs? Excuse me. कैटलिस्ट है या H2SO4 कैटलिस्ट है. but1ene No, you have to write the mechanism as well, please. I apologize. Done? You have to assign which one is major, which one is minor, and everything. Okay, 1, 2, 3, 4. This is butadiene. Okay, bacho. Now H goes to this carbon or H goes to this carbon. Number 1, number 2. So number 1 पे जाएगा तो major होगा ना? Okay, so CH3, CH2, CH, and then OH, and then CH3. Okay? और दूसरा क्या है? The other one is CH3, CH2. I just putting it together. CH2OH. Either this is butane 2-ol and this is butane 1-ol. Let's see the mechanism. What about the mechanism? Here I tell you to write like CH3, CH2, CH, double bond CH2. And then it becomes HOH. Now please pay attention. What happens here? This side is positive, this side is negative. So पहले इस पे कौन attach होगा? H या OH? Because electrophile attach hota hai. In order to attach electrophile with the carbon, you need electron pair. Where that electron pair? Yes, the double bond electron pair is used to make a bond with this H. And in order to accept, it has to break this bond and make it OH. No, the mechanism is straight up right side. No, the curly arrows only. Mechanisms, curly arrows are actually the words which we are speaking right now. So, but you can't say in words, you have to say in these arrows. Okay? Now, carbon number 1 and 2 both can attach electrophile. Therefore, they're not one because it's an unsymmetrical alkene. So, there'll be two type of unsymmetrical mean having different number of hydrogens with the carbon of the double bond. So, there'll be two types of carbocations. There'll be two types. In the first one, let's say carbon hydrogen electrophile goes to the carbon number 1. If it goes to carbon number 1, then carbon number 2 will be the electrophile, okay? And 1 will become CH3. And the other possibility is KH goes to carbon number 2, then the other electrophile would be CH3, CH2, CH2, and in that case, the other CH2 would be the positive, okay? So here are the two possible chances of being carbocation. Now, these two carbocations, out of these two carbocations, this one is what? Primary carbocation. And what about the other? That's a secondary carbocation. So in this case, now you have to look for, as soon as the carbocation formed, we know the carbocations are very unstable. So as soon as they are formed, we know the carbocations. What about this? It is stable or unstable? Which one? Secondary is stable as compared to primary. So it means it's going to survive and go in the next step more as compared to the one that is down. So this OH negative is now going to come and attach with both of these carbocations, but the one with this, what is this? The secondary are more stable. So what is formed then? It is CH3, CH2, CH, OH, and then CH3. Okay, and that's why it's a secondary carbocation which is more stable, hence this is the major product that is formed. Or more stability की reason भी वो पूछते हैं. Why more stable? Why more stable? Yes, two alkyl groups attached, a lot of positive inductive effect. Both of these alkyl pass their electrons towards carbocation, more positive inductive effect, and as a result, more stable. Here it is. So it becomes CH3, CH2. So primary carbocation के साथ लिख लें, it is unstable. I hope you got it now. Excuse me, please. आप कह रहे थे? Now you got it? Yes. So unsymmetrical alkenes, whenever they are added with HOH or HBr. So two type of products and how their variations occur. Okay, is it clear now? Yes, sir. Okay, now, right. So any question, please? किसी को कोई? Yes, sir. You want to write it? Okay, go ahead. It's okay. I can wait. Okay, I'm going to give you one more example in the meanwhile. Please write down CH3, C, double bond, CH2. Plus HCl. Can you please write the products and should we show the mechanism? Oh, yes. Plus HCl. Is it unsymmetrical alkene? Then there'll be two products. Yes. And they will the Marconi curves addition. Yes. What is the product? Two products. Two products. CH3, C, CH3, Cl, and then CH3. One of them is this. The other one is CH3, C, CH. CH3, CH, CH3, CH3, CH2Cl. CH2Cl. Which one is? The first one is major, the second one is minor. First one is major. Look, this hydrogen that goes to this carbon, and the other option is the hydrogen goes to this carbon. Which carbon has more hydrogens? No, no, this out of these two. Which one? Sorry? So that will be when hydrogen goes to one, that'll be major. Okay, in mechanism, what did you do? Okay, help me. CH3, CH3, double bond, CH2, and here is the HCl. So what is the first step? Who is going to add up? No, the electrophile or nucleophile? इलेक्ट्रोफाइल और उसको अटैच होने के लिए जो इलेक्ट्रॉन पेयर चाहिए वो कौन देगा? The double bond वाला electron pair will be used to attach hydrogen. So what will be formed? CH3 C. अब किसके साथ अटैच होगा? फर्स्ट वाले के साथ अगर अटैच होगा वो CH3 बन जाएगा. This will become a carbocation. अब ये कौन सा कार्बोकेटाइन है? या चलें पहले दूसरा ऑप्शन देख लेते हैं. What is the other option? What is the other option? Doesn't the arrow also go from the double bond to this? Yes, no, this arrow. This breaks to become Cl negative. Okay. Second product क्या होगा? What is the second product? CH3, CH, CH3, and then CH2 positive. So this type there, these are the two carbocations. This is what? Primary. And what about that one? Yes, that's a tertiary carbocation. So now it's a huge difference in the stability. So tertiary carbocation is what? More stable. Okay. This is what? Less stable or unstable. So which one? The Cl negative is going to add up to both these carbocations. Obviously, as this carbocation is more stable, so more number, obviously. So इसके साथ add हो जाएगा. तो जब Cl will be attached with the center carbon, CH3, C, CH3, CH3, and then here is the Cl. There's three types possible. Sorry. Like one is primary, the one is secondary, and one is no. तीन तो बन नहीं सकते ना, दो ही कार्बन है जिन पे डबल बॉन्ड है. तो उन्हीं में से कोई, हाँ, दो से ज्यादा डबल बॉन्ड हो तो यस डाइन में हो सकता है. ओके. नाउ इन दिस केस Cl नेगेटिव गोस हियर और ये क्या बन जाएगा? लुक एट दिस. व्हाट इज फॉर्म्ड? CH3, CH, CH3. विच वन इज मेजर बच्चों एंड विच वन इज माइनर? और वो क्यों मेजर है? क्योंकि उसका जो कार्बोकेटाइन था इंटरमीडिएट, दैट वाज टर्शियरी एंड मोर स्टेबल. Right, that's the reason. Okay, that's all about this electrophilic addition reaction. Oxidation of alkene next. No, we have 5 minutes. Oxidation of alkenes. No, halfway. Oxidation of alkenes. नहीं, मॉक्स तक तो हो जाएगा. Oxidation of alkenes. Number 1, mild oxidation. Pay attention. Number 1 is the mild oxidation. Please pay attention. When alkenes are mixed with, pay attention, cold dilute alkaline KMNO4. Pay attention, please. When they are mixed with cold dilute alkaline KMNO4, the condition is room temperature. What happens? Look, CH2 double bond CH2. Please pay attention. Cold dilute alkaline KMNO4. Now please pay attention. KMNO4 ko, whenever we write in the organic equation, we use its symbol. And what is the symbol of KMNO4 or K2Cr27? O. Plus dilute है तो मैं साथ पानी लिख देता हूँ. What happens when you add alkene with KMNO4 at room temperature? ऑर्गेनिक में इसको HOH लिख देता हूँ. उसकी वजह ये है कि ये देखें, ये H और ये O मिलके एक OH बना देते हैं और दूसरा OH इधर चला जाता है. So whenever alkene undergo mild oxidation, diol बन जाता है. So product is diol. So ethane 1,2-di. Double bond is converted to single bond and both these carbons have now OH. So what is formed? Ethane 1,2-diol. So in all these cases, हमेशा diol बनेगा बच्चों. Right? The KMNO4 symbol is O and dilute mean water है. So इसका मतलब है जब भी. So it's very straightforward reaction. कि whenever alkene undergo react with, look, I write like this: MNO4 negative / OH negative and room temperature. So both these carbon, double bond converted to single bond and they get OH. So CH3, CHOH, and then CH2OH. So propane diol is formed. Okay. Similarly, if this is CH3CH, इसका क्या product होगा बच्चों? If cold dilute KMnO4 at room temperature, RT mean room temperature. And even what will be the product for this? For this, please. Carbon number 2 and 3 contain double bond, na? Yes, butane 2,3-diol. Even if it's like this, and we reacted with KMnO4 at room temperature, what is the product? Cyclohexane. I think. OH. No, hexane. OH. यही बनेगा ना? 2,3-diol. Hexane 2,3,1,2-diol. Yeah, but naming we just forget it. 1 and 2. Where the OH is attached now, that is carbon number 1, 3, 4. But forget about the naming. What about this one? CH3, CHOH, and then CHOH. So this is how the mild oxidation of alkene takes place, Bacho. The other type is a strong oxidation. We'll continue this tomorrow. Thank you.